Hi. In this video, we are going to start our discussion of circles. So many of you might already be familiar with the topic. I will not go into the theory in too much detail. I will prove the important relevant things and we'll just do a revision of the theory. It might take one or two videos and we'll finish the theory for the chapter. And then we'll look at some problems, right? So let's begin. So first of all, what is a circle? The circle is the locus of a point in the plane which moves in such a way, which moves so that its distance from a fixed point is always constant. Its distance from a fixed point is always constant. That fixed point is known as the center of the circle, and the distance, which is constant, is known as the radius. So now the locus of this circle can be gotten by distance formula. So you can say x minus x1 whole square plus y minus y1 whole square is equal to r. Here x1, y1 is the fixed point or the center of the circle, and r is the radius. So if you expand this or square it out, you'll get equation of the circle like this. Y minus y1 whole square is equal to r square. So this becomes your basic circle equation. And this is a circle with center at x1, y1 and radius r. If your center was at the origin, the equation would look like x square plus y square is equal to r square, right? So that is the center 0, 0. Now, what is the general equation of a circle? So in general, you can have an equation of a circle like this. This is the standard equation of any 2-degree curve. In this equation, it will be a circle, first of all, if discriminant is not equal to 0, because discriminant equal to 0 means it's a pair of straight lines. So discriminant is not equal to 0, A is equal to B, and third condition is H is equal to 0. So basically what we have is, it should not be a pair of straight lines, and the coefficients of x square and y square should be same, and there should not be any xy term. This term should be 0, right? So in that case, the equation starts looking like this: ax square plus ay square plus 2gx plus 2fy plus c equals 0. And because a is non-zero, if a was 0, then obviously the equation will not even be a curve. It will be a straight line. So a is non-zero, so we can divide by a everywhere. And we can write this like this: 2g by ax plus 2f by ay plus c by a is equal to 0. And basically, this becomes your standard circle equation. So it is x square plus y square plus 2g dash x plus 2f dash y plus c dash equals 0. This is the equation of a circle in the standard form, right? So what we will do now is analyze what is the center and the radius of this circle, right? So you can do that in a simple way. You have x square plus y square plus 2gx plus 2fy equals plus c equals 0. We will do the method of completing the square. So we'll collect all the x terms together, add a g square and a minus g square, and then the y terms together, add a f square and a minus f square, and then plus c, right? So here, these three terms become x plus g whole square. These three terms become y plus f whole square. And on the other side, you have g square plus f square minus c. Now, if you compare this with x minus x1 whole square plus y minus y1 whole square is equal to r square, we can clearly see that the center of this circle x1, y1 is minus g minus f, and the radius of the circle is root over g square plus f square minus c. Now, obviously, if the circle has to be real, g square plus f square minus c should be greater than 0 for a real circle. If this is not greater than 0, then you don't have a real circle, you have an imaginary circle, right? So these are the conditions. If g square minus f, g square plus f square minus c is 0, then in that case you have a circle with 0 radius. So technically it is just a point, right? So finally what we can say is the standard equation ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equals 0. This standard equation represents a circle if del is not equal to 0, and del, you know, we have discussed earlier, is abc plus 2fgh ah square minus bg square minus cf square, right? Second is a is equal to b and both are not equal to 0. Third is h is equal to 0. And fourth is g square plus f square minus c is greater than equal to 0 for it to be a real circle, right? So that is the condition for this to be a circle. Now we move on and we'll start discussing some of the theory that is important for you to know. Another type of circle equation can be written equation of circle having x1, y1 and x2, y2 as the endpoints of diameters, as the endpoints of of a diameter. So in this way, like we can write an equation of a circle in this case also. So think about it. This is a circle, and if x1, y1 and x2, y2 are the endpoints of a diameter, then the center is the midpoint here. You can write the equation in the standard form also. You can basically figure out the center and the radius. So center would be the midpoint of these 2 points. Radius would be the distance of C to this point or to this point. However, there is a nicer way to do it. You can say locus of a point P x comma y, which lies on this circle. Since this is a diameter and this part is a semicircle, you can say that this angle must always be 90 degree. From basic geometry, we know that angle in a semicircle is always 90 degree. Therefore, what we can do is take advantage of that fact by writing the product of the slopes here and the slopes here should be equal to -1. So we'll get y minus y1 by x minus x1 times y minus y2 by x minus x2 is equal to -1, right? And now we can rewrite this like this: y minus y1, y minus y2 is equal to minus of x minus x1, x minus x2. And finally, the equation of the circle becomes x minus x1, x minus x2 plus y minus y1, y minus y2 equals 0. So this becomes the equation of a circle having x1, y1 and x2, y2 as the endpoints of its diameter, right? Now, in some cases, you might get a situation like this. The equation of a circle passing through three non-collinear points. Non-collinear points. And the 3 points are given: P x1, y1, Q x2, y2, and R x3, y3. So how do you find the equation of the circle in this case, right? So actually the method here is simple. You have x square plus y square plus 2gx plus 2fy plus c equals 0. This is my standard circle equation. And what we have to do is we have three equations because P, Q, and R lie on this circle. P, Q, and R will satisfy the equation. So if you put that here, you get x1 square plus y1 square plus 2gx1 plus 2fy1 plus c1 equals 0 plus c equals 0. c1 is not a constant. You have just put x1, y1 into the circle equation. Second result is x2 square plus y2 square plus 2gx2 plus 2fy2 plus c equals 0. And third result is x3 square plus y3 square plus 2gx3 plus 2fy3 plus c equals 0. Now, if you solve these three equations, you have to find out the value of g, f, and c. Find g, f, and c by solving these three equations. Because x1, y1, x2, y2, and x3, y3 are known, there are only three unknowns in these equations, right? So you can actually solve and find the values of g, f, and c. If you get the g, f, and c values, that is your circle equation, right? You put that in this equation. However, in the exam, if it becomes a little too difficult to solve these equations, there is a way to remember the answer as well. However, I would recommend that you only do it once you have tried solving the equations. So what I will tell you right now is the way to remember the equation of the circle passing through 3 points, right? So here, first of all, you will create a determinant x1, y1, 1, x2, y2, 1, x3, y3, 1. This has to be multiplied with x square plus y square plus. Now you will replace columns in this determinant one by one with C1, C2, C3. So I will tell you what C1, C2, C3 are. So C1, C2, C3. This is y1, y2, y3. I have replaced the first column. 1, 1, 1. And since I have replaced the column involving x, here the coefficient is x multiplied by x. Plus then you keep the first column as it is, and you keep C1, C2, C3 here in the second column with the y, and you multiply it with y. And finally, you keep both of the first and second columns, x1, x2, x3, y1, y2, y3. y1, y2, y3, and you keep C1, C2, C3 at the end in the third column. And this is the constant term equals to 0. This becomes your equation. And here, what is C1, C2, C3? C1 or Ci is minus of xi square plus yi square, where I can be 1, 2, or 3. So C1 will be minus of x1 square plus y1 square. C2 will be minus of x2 square plus y2 square. And C3 will be minus of x3 square plus y3 square. Right? So these are the constants C1, C2, C3. And this equation gives us the direct answer in case you have 3 points lying on a circle. Okay. We just have multiple determinants here. You set up the first determinant involving x1, x2, x3, y1, y2, y3, and 1. And then you replace that first determinant with the columns of that determinant with C1, C2, C3, one by one. And this is how you form the equation of the circle. Now, let's try this method once and see if we are able to do this through this method, right? So, we have to find the equation of a circle passing through these 3 points 1, 2, 3, minus 4, and 5, minus 6, right? The first thing I will do is I will calculate C1, C2, C3. So C1 is minus of x1 square plus y1 square. So this becomes, this is my x1, y1, this is x2, y2, and this is x3, y3. So C1 is clearly minus 5. C2 is negative of 3 square plus minus 4 square. So negative of 25 it will be. And C3 will be negative of 25 plus 36. So that will be 61. So these are my C1, C2, C3. And my determinant, the first determinant is x1, y1, x1, x2, x3. So 1, 3, 5, y1, y2, y3, 2, minus 4, and minus 6 and 1, 1, 1. And this is multiplied with x square plus y square. Then the second determinant is I replace the first column with C1, C2, C3. So it will be minus 5, minus 25, minus 61, minus 61, and keep the second column as it is, 2, minus 4, minus 6, 1, 1, 1. This is with x. The third determinant is keep the first column as it is, replace the second column with C1, C2, C3, and keep the third column as it is. This is with y. And finally, first two columns are the same. So 1, 2, 3, minus 4, 5, minus 6. And replace the third column, minus 5, minus 25, minus 61. Right? This equation will be the equation of the circle. And this actually comes by the solution of the equations only. The method by which we get this is the same solution of the equations. But now we have to now check whether this is coming as a correct equation or not. So all you have to do here is evaluate all of these determinants. I hope you know how to evaluate determinants. It's not very difficult. So let's do it. The first determinant will be 1 times minus 4 minus minus 6. So plus 2 minus 2 times 3 minus 5. So minus 2 and plus 1 times minus 18 minus minus plus 20. So 2. So you have 2 plus 2, 4 plus 4. So 8. So this becomes 8 times x square plus y square plus now the second determinant. So the second determinant would be minus 5 times minus 4 minus minus 6. So plus 2 minus 2 times minus 25 minus minus 61. So 61 minus 25 is 36 and plus 1 times 150 minus minus minus. So negative 244, right? So this is minus 10 minus 72 and minus 50 and 44 minus 94, right? So this is becoming minus 94 minus 104 minus 176. So you have minus 176x, okay? And the third determinant is becoming, third determinant is clearly becoming 1 into minus 25 minus minus 61. So plus 61. So 36 minus minus 5 plus 5 into 3 minus 5. So minus 2 plus 1 into minus 183 minus minus, so plus 125. So you have 36 minus 10 and you have 125 minus 183. So 83 minus 25. So 63 minus 558. So minus 58, right? So this is becoming 26 minus 58. So you have 36 minus 68. So minus 32, right? So minus 32y. And finally, you have this term, which is the constant term, which will be 1 into 244 minus minus minus. So minus 150 minus 2 into minus 183 plus 125 again. And finally, minus 5 into minus 18 minus minus plus 20, right? So this is becoming again 94. This much is 58. So minus 58 minus 2. So plus 116. And here it is a plus 2 and minus 5. So minus 10, right? So this is 84 plus 116. So 200, right? So plus 200 equals 0, right? So you can see that you can divide all of it by 8. You get a minus 22 here, minus 4 here, and a 25 here. And the equation of the circle is coming out to be x square plus y square minus 22x minus 4y plus 25 is equal to 0. This is coming as my circle equation. And now you can check whether 1 comma 2, 3 comma minus 4 and 5 comma minus 6 lie on this circle or not. You can check it yourself, it will come correctly. So I wanted to show you an example to show you how to use this method. Obviously, there is other ways to do it. The other way to do it is to start with an equation. Start with an equation and put the 3 points in the equation and solve for G, F, and C, right? So we could have started like this. We could have done x square plus y square plus 2gx plus 2fy plus c equals 0. And in that I can put 1 comma 2, 3 comma minus 4 and 5 comma minus 6. And you will get 3 different equations which you have to solve for G, F, and C. So that is also a proper method to do it. However, you can use the discriminant method if that equation solving is something that is taking too much time for you, right? Now, the next thing in the theory is position of a point with respect to a circle. And this is pretty straightforward. If a circle equation is given like this, x square plus y square plus 2gx plus 2fy plus c equals 0. And if a point is p x1, y1, what you have to do is put this point in this equation. You will get x1 square plus y1 square plus 2gx1 plus 2fy1 plus c and evaluate this quantity. If this quantity is greater than 0, the point P is exterior of the circle, is outside the circle, right? If this point is less than 0, P is inside the circle. And if this point is equal to 0, then P is on the circle. So that explains how to find position of a point with respect to a circle. Now, another very important idea that you need to know is the idea of power of a point. So, power of a point with respect to a circle. Point with respect to a circle. So, anybody who has done a little bit of geometry knows that this is a very important idea. So, if you have a circle like this with a center C and radius of R, and you have a point somewhere outside P, right? The power of a point is defined as power of P is equal to PC square minus radius square. So what is PC square? PC square is the distance of the point from the center, and you have to square it and subtract the radius square from it. So technically we will see later that power of a point is also equal to the length of the tangent drawn from P to the circle. So basically it is equal to PT square also, right? Because the tangent drawn from P to the circle would be at T and this is 90 degrees. So PC square minus R square by Pythagoras theorem is equal to PT square, right? Now we can also do another thing. In case you have a secant line, that cuts the circle at 2 points A and B. So the graph is something like this. You have a point P here and you have like this PA and PB, right? And this is the center of the circle. And this point is x1 comma y1, right? Let's say the equation of the circle is x square plus y square plus 2gx plus 2fy plus c equals 0. Now, what you can do is equation of line through P, any line through P, which is x1 comma y1, can be written in the parametric form, can be written in the parametric form or polar form like this. You will have x minus x1 by cos theta is equal to y minus y1 by sine theta is equal to r, and here theta is the slope of this line. So theta is the slope of this line P, line PAB. So any point on the line, any point on line can be written as x would be x1 plus r cos theta, and y would be y1 plus r sin theta. And here r will be the distance of that point x comma y from the point x1 comma y1, right? So if you have point A and point B, these are both points on the line. So point A can be written as x1 plus r cos theta, comma y1 plus r sin theta. In that case, point A also satisfies the circle equation. So you can put this into the circle equation and you will end up getting a quadratic equation in R. So how do I do that? So I will say x1 plus r cos theta whole square plus y1 plus r sin theta whole square plus 2g x1 plus r cos theta plus 2f y1 plus r sin theta plus c equals 0. So you can clearly see that if you square it out and collect all the terms together, you will get a quadratic that looks like this. R square plus 2r, and inside this bracket we can collect x1 plus g cos theta plus y1 plus f sin theta, and plus you have some constants, and the constants would be basically x1 square plus y1 square plus 2g x1 plus 2f y1 plus c. These will be constants that will appear, and this will be equal to 0, right? Now this is the quadratic that comes after you have made it a quadratic in R, right? And after you have put the point P into the circle equation. So this quadratic has two roots, R1 and R2, and it has two roots because the second line was cutting the tangent, cutting the circle at 2 points A and B. So the distance of P from A is R1 and the distance of P from B is R2, right? So basically PA into PB is R1 into R2, right? And you can see here that the product of roots in this equation, product of roots here is equal to C by A, which is simply x1 square plus y1 square plus 2g x1 plus 2f y1 plus c, right? And this is clearly constant because it depends only on the position of point P x1 y1. All of these terms are fixed because x1 y1 was fixed, right? So what we have here is product of roots, which is PA times PB, is constant. Later, when we'll know the length of the tangent from Px1 y1 to the circle, you will realize that this distance is equal to Pt square, which is length of the tangent square. And we also know that Pt is the power of a point P, right? So finally, what we can say, combining both the things that we have learned just now, PA into PB is equal to power of point P square, or basically not power of point P square, power of point P itself is Pt square. And it is constant because it only depends on position of point P. So, position of P, x1 comma y1, right? So PA times PB is constant, and that is the result that you will be very useful. So basically what we are saying is, if you have a circle and a point P is fixed, you can draw any set of secant lines, PA, PB, PC, PD, PE, PF. So PA into PB is equal to PC into PD is equal to PE into PF, and is all equal to Pt square, where Pt is the length of the tangent to the circle, right? So this is the consequence of power of a point. Okay, the next thing that we look at is the equation of a chord joining 2 points, A, which is x1 comma y1, and B, which is x2 comma y2, on a circle S. And the circle equation can be written as x square plus y square plus 2gx plus 2fy plus c equals 0. So this equation is written as s is equal to 0, right? Now, the way you can find it is you can first find the middle point of that chord. So you can say midpoint of the chord AB. Midpoint is x1 plus x2 by 2, comma y1 plus y2 by 2. And we also know the center of the circle. Center of circle is minus g minus f, right? So this is my circle, this is my chord, A and B are here. Center is C here. And let's say P x comma y is any point on the chord, right? So what we can say is midpoint is M. We know that CM line is perpendicular to AB, right? So we know CM will be perpendicular to AP, where P is any random point on the chord, right? What is the CM slope? The slope of CM, so let's do the condition for this, right? So slope of CM would be y1 plus y2 by 2 minus f, so plus f, divided by x1 plus x2 by 2 minus g, so plus g. This is the slope of CM times the slope of AP will be y minus y1 by x minus x1 equals minus 1, right? And basically, now you have to simplify this equation. You already have an equation involving constants that you know about. So if you simplify this equation, you will end up getting the chord, right? So I don't want you to remember the equation of the chord. You can just construct it like this. What are we doing? We are taking the points A and B, finding the midpoint. We know that CM is perpendicular to AP and P is any random point on the chord. So write the slope of AP, multiply it with the slope of CM and say that the product should be minus 1. And if you simplify this, you will get the equation of the line, right? You can also realize here that both x1, y1 lie on the circle. So x1 square plus y1 square plus 2gx1 plus 2fy1 plus c equals 0, and also x2 square plus y2 square plus 2gx2 plus 2fy2 plus c equals 0. So this information is also available to you, right? So don't have to remember the chord equation. You just can get it whenever required, right? Okay. Now, the next thing that we look at is the equation of tangent to the circle. Equation of tangent to circle. So again, there are multiple ways to do tangent. If the point of tangency is given, point of tangency is x1, y1, if it is given, and the circle equation is given, then we'll follow the same method that we have used in conic sections, the replacement method. So I'll write simply the equation of tangent in one step. G x plus x1 plus f y plus y1 plus c equals 0. The second method is if you want to find the equation of tangent using the slope form. So if y is equal to mx plus c is tangent to, let's say, the circle x square plus y square is equal to a square, right? So what is the condition on C here? So we'll solve the line equation with the circle equation. We'll get x square plus mx plus c whole square is equal to a square. And since it is tangent, the discriminant here must be equal to 0. You have m square x square plus x square plus 2mcx plus c square minus a square is equal to 0. So you have m square plus 1 x square plus 2 mcx plus c square minus a square is equal to 0. And putting discriminant equal to 0, you get 4m square c square minus 4 times c square minus a square times m square plus 1 equals to 0. So you get minus 4 c square m square minus 4 c square plus 4 a square m square minus a square, so plus 4a square. And here you have 4m square c square, which gets cancelled here. So finally, what we are getting is this is equal to 0. So you're getting c square is equal to a square 1 plus m square, right? So c is equal to plus minus a root over 1 plus m square. And therefore, the equation of the tangent becomes y is equal to mx plus minus a root over 1 plus m square, right? That is the equation of the tangent. And you can also find the point of tangency by saying in this quadratic, the x coordinate has to be minus b by 2a. So minus 2mc by m square plus 1, right? And minus 2mc by 2 times m square plus 1. So it is minus cm by m square plus 1. And c is a into root over 1 plus m square, right? So you will get minus m into a minus am by root over 1 plus m square is the x coordinate, right? And once you know the x coordinate, you can put mx plus c there and find the y coordinate also, right? So basically, we can find the equation of tangent with a given slope, and we can also find the equation of tangent if you know the point of tangency, right? So that is how you do that. Okay, so we have discussed the intersection of a straight line with with the circle. So the straight line will be tangent to the circle if the discriminant is 0. You can do this, however, in a different way also. If you have y is equal to mx plus c, and we have the circle x square plus y square plus 2gx plus 2fy plus c equals 0. Another way to think about it is a geometrical way. So suppose this is a line and this is supposed to be tangent, and this center of the circle is minus g minus f, and the radius is known. We know that the perpendicular from minus g minus f to the line y is equal to mx plus c must have length equal to radius, right? So perpendicular from minus g minus f to line y is equal to mx plus c, that perpendicular distance can be less than, equal to, or greater than the radius, right? And if it is less than, the line is a secant. If it is equal to, the line is a tangent. And if it is greater than the radius, the line does not intersect the circle, doesn't intersect, right? So this is a standard method also, which is much faster than trying to solve the equations and putting discriminant equal to 0, right? So what we can do here is basically drop a perpendicular from minus g minus f to this line. So you will get basically what? Minus f minus mx. So plus mg minus c mod by root over 1 plus m square should be less than, equal to, or greater than the radius, which is root over g square plus f square minus c. So that upon squaring, that will immediately give you the condition that you need, right? So use this result also if required, because the geometric way will be faster than trying to do it algebraically, right? The next idea is length of tangent. Length of tangent from a point to a circle, right? So if the equation of the circle is s, x square plus y square plus 2gx plus 2fy plus c equals 0. So the center of the circle is minus g minus f. And you have a point here p, x1, y1. So all you have to do to find length of tangent is find the length of pt. So we can easily say that that will be equal to pc square minus radius square, right? So we know pt square is equal to pc square minus radius square. And pc square will be what? x1 plus g whole square plus y1 plus f whole square minus radius square is g square minus f square plus c, right? So you can see here This will become x1 squared plus y1 squared plus 2gx1 plus 2fy1 plus g square plus f square get cancelled and plus c comes, right? So this is coming as the length of pt square. And notice what this is. This is like putting this point in the circle equation. This point x1, y1, if you put in the circle equation, you will get x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. So length of the tangent comes if you put the point into the circle equation, that is the length of the tangent square. So PT, the length of the tangent, is written as root S1, where S1 means what? It means you have put the point x1, y1 into the circle equation, right? So that becomes your length of tangent. In general, you can make two tangents to a circle from an external point. That is obvious if you use the equation of the tangent in the form y is equal to mx plus a root over 1 plus m square, and say that point P x1 y1 lies on this line, on this tangent, then you will get y1 is equal to mx1 plus a root over 1 plus m square, and you will get y1 minus mx1 is equal to a root over 1 plus m square. You can square this and make a quadratic in m. And this quadratic in m will have two roots in general. Sometimes it can have zero root or only one root, which is equal roots. It will have zero roots if the point is inside the circle, then no tangents are possible. It will have two roots if the point is outside the circle. And then in that case, two tangents are possible, right? Okay. Then the next thing that we have is the parametric equation of a point on the circle. So if you have a general circle like this, and the equation of the circle is x square plus y square is equal to r square, then obviously any point on the circle can be represented in polar form, and x can be written as r cos theta and y can be written as r sin theta. So a random polar form point on the circle will be r cos theta comma r sin theta. In general, if the circle radius and center were not at the origin, it was a shifted circle, right? In general, if the center is h comma k, again you can do the same thing, but this time you'll say x minus h is r cos theta, and you'll say y minus k is equal to r sin theta. So in general, the coordinates of a random point on this circle would be h plus r cos theta, comma k plus r sin theta. So that will be coordinates of a point on a circle which is not centered at the origin, right? In the parametric form. Now, one important equation that you should remember is equation of chord joining two points. And these two points are mentioned in the parametric form P alpha and Q beta on the circle x square plus y square plus 2gx plus 2fy plus c equals 0, right? So what is the equation of the chords joining two parametric points here, right? So radius of the circle is clear. It is g square plus f square minus c. And the parametric point alpha and beta will be, P alpha would be basically minus g plus r cos alpha, comma, minus f plus r sin alpha. I'm shifting the center, h and k are minus g minus f. And q point beta would be minus g plus r cos beta and minus f plus r sin beta, right? These are my 2 points P and Q. Now the equation of straight line joining these 2 points is simple. You write y minus y1 2-point form. So y minus y plus f minus r sin alpha by x minus x1. So x plus g minus r cos alpha is equal to y2 minus y1. So in that case, you will get r sin alpha minus r sine beta divided by r cos alpha minus r cos beta. So we are simply doing 2-point form. Once you have written these 2 points, we are doing 2-point form to find the equation of the line. However, it will be useful for you if you try to remember the final expression. You can simplify this, or you can use this directly. Whenever a problem comes, you set up the equation like this. Or you can remember the final form of the equation of the line joining these 2 points. And this final form, if you remember, it will be a little faster for you. So I would suggest you to remember this one. And the equation of the chord joining these 2 points can be written like this. X plus g cos of alpha plus beta by 2 plus y plus f sine of alpha plus beta by 2 is equal to r cos of alpha minus beta by 2. So notice it is similar to the parametric forms joining 2 points on an ellipse and stuff. But you should remember this result. Here G, F and all represent the center of the circle. So if the center of the circle was origin, you will have simply x cos alpha plus beta by 2 plus y sine alpha plus beta by 2 is equal to r cos alpha minus beta by 2, right? So right now we have learned equation of chord joining 2 parametric points on the circle. I will stop at this point because we have covered quite a lot of theory. We will continue with more theory in the next class, and I will try to finish more or less the important ideas, especially theoretically, by the next class. We will do a lot of problems on circles, so don't worry about that. However, make note of what we discussed in today's class. Try to do the derivations yourself. Go through each and every point that we did and see the derivations yourself if you are understanding them. One more class and the theory for circles will be done, and then we'll do problems. So that should be a good revision for you as you prepare for your exams. So that's all for now, and I'll see you in the next class. Please do share the channel with your friends in your WhatsApp and Telegram groups. I need your support to help reach more students. If you like the videos and share the channel, it will definitely help me grow. So please help me with that. That's it for now. I'll see you next time.